In this video, we are going to solve some problems which are related to geometric sequence and series. So this is our lesson 8 for chapter 1. Chapter 1 still talks about the sequences and series. So our first problem will be, we have the third term of a geometric sequence is 32 and its sixth term is 2048. Find the common ratio and the first term. So here we are just given an information, which is we have a sub 3, and that is 32. This gives us n is 3. Then we have a sub 6, that is 2048, and that is equals to n equals 6. So what we're going to do is we will create two equations, okay, out of our general term, which is Rn minus 1. Okay, so let me just clear it. That's a sub n equals a sub 1 times r raised to n minus 1. So let's try to create an equation with this. So with that information and using this general term, we will have, so our a sub n will become 32. So that is 32 equals, our a sub 1 is unknown. We write it as a sub 1. Our r is also unknown. But we do have n, which is n equals 3. So that's 3 minus 1. This in turn gives us 32 equals a sub 1 times r square. Okay. So this will be our first equation. Our second equation will be utilizing this information. It's the same. We have 2048 a sub 1 times r raised to, what is our n in this case, is 6. This 6 minus 1. This in turn gives us this equation. 2048 is just a sub 1 times r raised to 5. So here, as you can see, they are both, we can rewrite further the 32 as, let's just write it here. Okay, the 32 a sub 1 times r square, we can simply divide both sides by r square. So this gives us, our resulting equation will be cancel out. So that's ang resulting equation will be a sub 1 equals 32 r square. So this gives us our, and later on we'll show you what's the purpose of rewriting this equation. The subject becomes a1 a sub 1, or the first term in terms of r. So here we have 2048 a sub 1 equals r raised to 5. We can divide both, times r raised to 5. We can divide both sides by r raised to 5. So this becomes cancelled out. So we have a sub 1 equals 2048 divided by r raised to 5. So here's the thing. Notice that they are both equal to a sub 1. Meaning, since they are both equal to a sub 1, they are also equal. By transitive law of equality, the 32 over r square is just equal to 24/8 over r5. So we can rewrite that as 2048 over r5 equals what's that again? 32 over r square. So by this case, I guess we can multiply both sides by r5. That's the LCD. So what's left in this left side is just the 2048. By division, the r raised to 5 will be cancelled out. Then by division as well, r5 and r square will become 32r cubed. Then we can just simply divide both sides by 32. We get 2488 divided 32, we get 64. So this one is only r cubed. Since this is cube, we take the cube root. We take the cube root of 64, we take the cube root of r cube. So the cube root of r cube is r, which is our desired common ratio here. So cube root of 64 is just 4. So we have already our common ratio r. Okay? So since you already have a common ratio r, we can use this, the simpler equation between the two, to get our a sub 1, because you're looking for a sub 1, the first term. So we're done with we are done with the r, which is the common ratio, and we get what was that again? R equals 4. Next is we will find the first term. So notice that in this equation, we simply substitute that in r. So we know that our a sub 1 is just 32 divided by r square. And that gives us 32. Our r is 4, which is this one. 4 square. That gives us 32 over 16. That gives us 2. Okay, so imagine your first term is 2, your r is 4. So that gives us the sequence. It's like giving 2, the first, times 4, because r is the constant value being multiplied to the terms, to get the other terms. 2 4, no 2 times 4, that becomes 8 here. Okay, times 32, 128. Notice that if you're going to continue this pattern, it's really correct that the third term is actually 32, as what is said in the given. If you're going to continue, you'll get 6 terms, 2048. We just ended it at 4 terms. That is our first problem. Let's proceed with the next problem. So here we have the terms 3p1, 5p plus 5, and 12p minus 4 are consecutive terms of a geometric sequence. We will find the value or the possible values of p if there are more than one. Possible values of p and the common ratio r. Okay, common ratio r. So let's try to find first the value of p, because that's the only way we can find our common ratio r. So how do we do this? Notice that if we have the sequence, the basic property of a geometric sequence is like this. Let us say 2, 4, 8, 16. As you notice, if you're going to divide 4 by 2, it's the same as if we're going to divide 8 by 4. It's the same as we're going to divide 16 by 8, as long as they are consecutive terms of a geometric sequence. So the same thing, if we're going to divide this by this one. So let me just write it again in. If we're going to divide this by this one, the second term by the first term, that's going to be 5p plus 5 divided by 3p minus 1 equals the same thing as if we're going to divide this by this one. The same logic with this. Okay, so we say 12p minus 4, 5p plus 5. Okay, so here what we're going to do is we will multiply. So the LCD is the two denominators, because they are relatively prime. There's no common to them, so we can multiply. Our LCD is 3p minus 1 times 5p plus 5. So let's multiply this both sides by simply 5p times 5 times 3p minus 1. Then the same thing in the other side, we'll multiply this by 5p plus 5 times 3p minus 1. Notice that by division, this becomes 1. or becomes cancelled out, or that's become 1. Then this one is also cancelled out. So we are left with 5 in the left side. We are left with 5 plus p5. Okay, 5p plus 5 times 5p plus 5. Okay, so we are left with 5p plus 5, or you can just square it actually, plus 5. And the other side we have 12p minus 4 times 3p minus 1. Simplifying it further, on the left side we get this one, 25p square plus 50p plus 25. The other side we'll get 12p square, now 36, minus 24p positive 4. Okay, so let's write that in the other one. So the left side is 25p square plus 50p plus 25, that is just equals to 36p square minus 24p plus 4. So let's make this right 0. So by how can we do that is by simply saying minus 25p square. So we also minus 25p square here. Then we say minus 50p. We also minus 50p here. Then let's erase first this one. Then we have minus 25. We also say minus 25 here. So what is left is we have, on the left side this becomes all 0. The 36p square and the 25p square, that becomes 11p square. Then this becomes 74p. This becomes negative 21. So as you notice, this is a quadratic equation. So if you don't know how to factor this one, okay, if you don't know how to factor this one, you will be utilizing this idea. Okay, the quadratic formula, p equals not x, because our equation is in terms of p, so you're not supposed to be using p. X equals, so you say p equals, what's the quadratic formula again? Negative b plus minus square root of b square minus 4ac all over 2a. So our a, go back, our a is 11, our b is negative 74, our c is negative 21. So let's simply substitute it here. Negative b, that's negative 74, so that becomes positive 74, plus minus, this is negative 74 square minus 4. A is 11, c is simply negative 21, all over 2 times 11. So we have 74 plus minus, what's inside is, of course the below becomes 22. What inside the radical is simply 6,400. Okay, so doing this further, we have 74 plus minus, what is square root of 64,000? That's 80. Since it's plus minus, there's going to be two values, one being the positive, so this is p equals the positive one, and that gives you 74 plus 80, that gives you I think 7, because that's 154 divide 22, that is equals to 7. So we have now our first value for p, which is 7. Our second value for P is 74 minus, because there's this one is plus minus 80 equals 22. That gives us negative 6 over 22, and that gives us negative 3 over 11. Okay, so that's it. We have our possible values of P, the P equals 7 and the P equals negative 37. So now let's try to what do you call this, substitute that in the terms 3p minus 1. Okay, so we have 3p minus 1. So again, we are done looking for a, which is the value of p. Now is the common ratio. Okay, the common ratio. Okay, so let's try a look here. 5p plus 5, then we have what they call this, 12p minus 4. So let's try the 7 if it forms. So when p equals 7, okay, when p equals 7, this becomes 3 times 7 minus 1, which is that is equal to 20, right? 21 minus 1 is 20. This one becomes, when p equals 7, this becomes 5 times 7 plus 5, that becomes 40. And this becomes 12p times 7 minus 4, and that becomes 80. Notice that here 20 20 to 40 to 80, here you can see that the common ratio is 2. Okay, the common ratio is 2. So what if p is negative 11 3? Let's see if that gives us a geometric sequence. Okay, sometimes we'll see, we'll just see. That's negative 3. What's the that's it here, negative 3 over 11. So let's try. When p equals negative 3 over 11, the 3p minus 1, this one, becomes, what happened? 3 negative 3 over 11 minus 1. That gives us negative 20 over 11. So how about here for the second 5p plus 5? So that's 5 times negative 3 over 11 plus 5. So we have 40 over 11. Then the third one, this 12p minus 4, that's 12 times negative 3 over 11 minus 4. That is simply, we'll see, negative 80. Okay, what is that? Negative 80 over 11. So let's try to divide. Of course there is, okay, there is actually. Okay, so the r here is negative 2. R here is negative 2. So you can see, multiply it by negative 2, multiply it by negative 2 again. Okay, so in this case, so there are two values of p, there are also two values of r, because two of them work. So look at this, 20, 40 and 80 becomes a geometric sequence. Negative 20 over 11, positive 40 over 11, negative 80 over 11 also form a geometric sequence. So in general, when p equals 7, r equals 2. whether and then when p equals negative 3 over 11, so where do we get this? A while ago we solved this using quadratic equation. We have r equals negative 2. Okay, so that's it. How about our next problem? So here, the original price of a car is 900,000. If the yearly price depreciates, meaning it goes lower by 2% of its previous price, find the price of the car in the 10th year. Okay, so we'll simply find the value after 10 years. Okay, so let's try. So it's like saying that our a sub 1 is simply the 900,000. Okay, then our r is simply the 3%, or you can say that is 0.03, or you can say that is just 3 over 100. Percent means per 100, 3 per 100. So we are looking for when n equals 10. So we simply use a sub 1. No. A sub n. A sub n equals a sub 1 times r raised to n minus 1. So let's try to look at here. We have a sub n, which is that is a sub 10. We are looking for that. Our a sub 1 is 900,000 times 0.03 raised to n minus 1. That's 10 minus 1 raised to 9. So that gives us simply, we have 900,000 times 0.03 raised to 9. So that is see, that's so small already. That is amounting to 17. Because it's so small, you can just write it like this way actually. Okay, that is like, then 10 raised to, how many is this one? 12 zeros after 10. So that's it. So that is so very small after 10 years. That's the recalculation works. So number 4. So number 4, we have here the area of each square is 3/4 of the previous square. Okay, so meaning if you have this square, this square, so if you have this square, you multiply it by 3/4, you get this square. Multiply it by 3/4, you get this, the area of this square. Multiply this again by 3/4, the area becomes this square. Okay, so the question is, if the pattern continues, so the first square is an 8 by m centimeter square. So given that this, each succeeding squares are 3/4 of their previous square, so find the total area until 10th square. Okay, until 10th square. Okay, so how do you do that? So it's like saying that our a sub 1, we're going to find the s sub n equals a sub 1 times, what's the formula again? One minus r raised to n all over 1 minus r. So do we know our, so we are looking for the sum, add all these 10 square, the area of this 10 square. So you have s sub 10. Okay, So here our a sub 1 is actually the area of this one. Okay, the first square. So what is that? An 8 by 8 square has an area of 64 because 8 times 8 is 64. So we know that our a sub 1 is 64. Then 1 minus, what is our r? Our r is actually, we have this because you know that, when we multiply this by 3/4, you get this. You get this area. Multiply this by 3/4, you get this by area. So meaning our r is 3/4 raised to simply 10. There. Okay. Then we have 1 minus 3/4. In turn, you'll get, okay, after if we're going to input that in calculator, we get 64 times 1 minus 3/4 you'll get around 989,527 all over 16,384. 1 minus 3/4 is 1/4. So doing this again, you'll actually get 989,527 all over 4,096, or roughly that is just simply 241. Okay, 0.58 something centimeters squares. Okay, so that's all for our some problems related to geometric sequence and geometric series.